Kia ora team, my name's Ben and this is...
Houston again.
Well done, still Houston. And Houston's going to talk us through...
what energy systems are used during a 100k run, what fuel and why.
Brilliant. Alright Mr. Houston, 100 kilometre race, what type of energy system are we doing?
Aerobic.
Aerobic, gorgeous. Now what's the benefits of using the aerobic energy system?
Produces a lot of energy per molecule of glucose or fat than anaerobic glycolysis.
Okay, good. Because if we break down glucose, so here's my glucose... Oh, what the... If we break down... We need... Oh, that's even... Hey! Okay. I need to go steal some pens. Because this is ridiculous. Come into the shot. Not too close. Okay, so when we break down glucose by glycolysis, we end up with...
2 ATP.
Good. And...
2 pyruvic.
Pyruvic acid molecules. Good. So, if it's anaerobically without oxygen, that's how much we get. So 2 ATP. But, if we have oxygen, then our pyruvic molecules go into the mitochondria. Good. So the mitochondria, and the first thing in the mitochondria is the Krebs cycle, and we get
2 ATP.
Another 2 ATP, and then we go to the
transported chain.
Good, electron transport chain, and we end up with another 32. So if we've got oxygen, we can get maybe 36 ATP from glucose, whereas if there's no oxygen, we can only get 2. So working aerobically is brilliant. What's the waste product of working aerobically?
H2O and CO2.
Good. So we get water and carbon dioxide. Is this a bad thing?
No.
No, because nothing toxic about water, we can use that. And carbon dioxide, can we get rid of it?
Yes.
And how do we get rid of it?
Breathing out.
Perfect. Okay, so these byproducts
do not cause immediate fatigue.
Brilliant. Okay. We've talked about the benefits of working aerobically. So what are some disadvantages? Dramatic pause.
Yeah, okay. Yeah. Because of the additional steps required in producing energy aerobically, it takes a lot longer to produce the additional energy.
Okay, so those additional steps, we broke down glucose into 2 ATP and pyruvic acid, then we needed oxygen to come in, then it had to enter the mitochondria, then we had to go through the
Krebs cycle,
then we had to go through the electron
transported
chain. Whoop, whoop. Good. So those extra steps take time, but is this a problem?
No, because you'll be running at a slow pace during the race.
Good. So if it's a 100k race, I don't need much energy at any one time because I'm not going to be sprinting it. Alright, so what is the main fuel source he's going to be using?
He's going to be using fat.
Good.
Because he has a lot more fat reserves than carb reserves.
Good.
But it requires a rich oxygen supply to break it down into good fatty acids.
Good. And what do we need to do to fat before it gets into the cell?
We need to break it down to free fatty acids before it can diffuse into the cell membrane.
So a problem with that is it's going to take
ages.
A long time. But is that a problem for this guy?
No.
Because he's working at a
slow pace,
long intensity. So it takes longer compared to carbohydrate, but that's fine because we're doing endurance and we don't need much energy at any one time. Boom!